All right, welcome back. We are COMP301 in the summer 2020 semester at Centennial, and it's week 12, part 1 of our broadcast. Today we're going to finish off what we started last week, which is an Intro to Data Science, Pandas series, and DataFrames. But before we get there, I just wanted to mention something about our test for next week. Remember that next week is our final test, and as I mentioned to you last week, I'm going to make this one a true-false multiple choice type test. Not because I don't think you can handle some kind of practical test, but rather that I think you have a lot of practical stuff coming at you starting next week, and I want you to be able to do something that's a little bit less intense, especially since some of the stuff that we've learned here in this course, Linux and Python all together, there's a lot of stuff to do. So what is the test going to cover? Remember that our midterm is done. So anything that we cover to midterm, I'm not going to cover again. It's really from the midterm on that I'm going to cover. So all the Python stuff that's going to be on your test, right? So the Python stuff, what we're going to be doing with that is I'm just going to ask you some true-false multiple choice questions. Of course, it's going to be open book. I'm going to give you 2 attempts over the period of time. And what's going to happen next week, starting on Monday and Thursday, I am not going to have new classes. There's not going to be new lectures. The last lecture for this semester for this course is Thursday. Thursday from 2:30 to 4:30 is the last semester, right? Thank you for that. So if that makes any sense to you. So Thursday at from 2:30 to 4:30 is our last lecture, and then next week what we're going to do is on Monday and on Thursday of next week I'm going to hold office hours, right? So I'm going to take care of all the marking and everything else, giving you feedback for everything you've done this semester, as well as any help when it comes to your tests, any technical stuff. Sometimes when you put a quiz together, if you don't have a stable connection, what happens is you have to be reset and all this kind of stuff. I'm going to be here around for that, but attendance will not be mandatory at all next week. I'm not going to cover new material. From a review perspective, there's nothing to, I'm not going to, I mean, I'll do a quick review maybe on the Monday, but it won't be something where I go through every single PowerPoint slide. But I'm going to tell you that everything is game after the second half, right? So anything from the second half on, from the Python stuff we learned all the way till today. All right, this is all, or sorry, till Thursday. It's all fair game in terms of what's going to be on there. My suspicion is, and I haven't finished the test, doing the test, it's going to be at least 50 questions. That's my suspicion. And roughly, you're going to get 50 to 55 minutes. So you're not going to have a lot of time to do each question. But the good thing is you'll have access to the internet, and you'll have access to your PowerPoint slides in order to get it done. So why is that? I mean, it sounds like it's pretty easy. And you know what? It is pretty easy. Why? I want you to have a chance to go through the material again. We haven't had a chance to do quizzes too much in the second half of semester because of the structure of the course, right? So I'm going to give you a chance to go through that whole thing again and look at the material. That's what this exercise is going to be for the midterm, or the final test. So don't panic. You'll get 2 attempts, and you'll get the best mark out of both attempts over the whole period. So you'll have from Monday approximately to Friday of next week to get it done, Friday at midnight. So you'll have that whole time frame, and again, the test shouldn't take more than 55 minutes to an hour to complete. All right, so you can do that twice for sure before your time is done. All right, so that's what's happening next week. Any questions around that? If you do have a question, yes? Excellent. And we're going to talk about it again on Monday. I'll make an announcement when the test is live that you can go and do it. Don't be afraid to get it done. What I would do though is I would look through the material. I think a good strategy when you do the test is look through the material first, so that before you do the test, you know in your mind, maybe you would have remembered where to look for that material, that you know that there's an answer to the question that I'm asking you. And remember that I'm going to use the material to make the test. So I'm not making the test from random sources. Anything I ask you is, chances are I've covered, right? So that, you're not going to, you shouldn't get blindsided and like, where does this question come from? Why is he asking me this question? anything that I've asked you is something we've covered in the material. Okay. All right. So hopefully that covers the things with the test. If you do have a question about the test, before the end of class, I mean, again, we're going to take this. I'm not sure if we'll take this all the way to 6:30 today. I always say that, but we'll see how it goes. All right. So for now, what I'm going to do is I'm going to pull up my VM. So please spin up your VMs, right? So we can get this going. I'm just going to make sure that I run Ubuntu. And my VM's taking its sweet time to spin up. All right. Yeah. Okay, so where last we left off, last week, in our previous episode, let's see. Yes, we were here. So I'm just going to make a copy of this and I'll paste it. And this will be, I'll rename this thing to, wait. Okay. 12. And I'm going to go into VS Code. And whenever my VM decides to come up, I'm going to swim to that new folder. And we've got some other work we've done over here. What I'm going to do is, just to be fair, I'm going to get rid of all this stuff and delete it. And I make a new one called main.py. Just that we have a fresh start, fresh slate, if you will. One thing to note is there is a pattern that before we start that I wanted to discuss with you, which is if I look at something called Python main, and it looks like Python underscore main, right? How does that work? Which is, it says a top level script, but I want to make a main environment, and a lot of times what you might see is this function if name is equal to main, right? If name is equal to main, then main. I don't know if you've ever seen this pattern. You must have seen this somewhere up online. I want to use this pattern today. So I'm going to kind of grab this stuff and I want to copy it and go back and paste it in. I want to talk about it, right? And this is the last thing we'll talk about it that's new, right? Other than, I mean, the intro to data science today. And we'll do one more thing on Thursday. I'll try and make it interesting on Thursday. Maybe we'll do a little bit of machine learning. We'll try, depending on how things go today. So what does this mean and why am I showing you this? Let's make this, I'm not sure why, but it's coming in a little bit low, and I think what I'd like to do is I'd like to change my preferences for my font size. Text editor font. I think I want to make this a little bit bigger today. And yeah, I think this is good. So, yeah, that's better. So, yeah. So how does this work? So what is if name? So what is if name? Name is actually referring to the name of this program. If name is equal to main, if this is the main file, then call main, right? Which is our main, program, main function, if you will, right? So that's what this does. This is kind of like a preprocessor command in some ways for Python. And you might see this pattern again and again. This is a common way of doing things. So again, if I was to run this, control backtick and run it, if I said Python and then call main.py, then you'll see that it says hello world. Okay. I just wanted to show you this because Sorry, I'm getting a question here from Seong. I absolutely think you can look at whatever you want. You can look at the PowerPoint. You can look at the book. Book's not going to really help you that much because the book doesn't maybe go into the detail that I've gone into. But any source you want, including internet, it's open book, open internet for the test. But you do have a limited time, so that's why I'm recommending looking at the PowerPoint slides might be your best bet. All right, let's get back to this. So that's kind of a pattern that you're going to see. If name is equal to main, and then do your main thing. And this is not a bad way. I think it's a good way of handling things. This way you can just run python main.py, and everything comes from this main function. This is like the entry point into the program. I think this is a good way of making it work. All right, so what we're talking about today is this idea of, we've talked about NumPy's array, the ND array, which is an awesome array. It gives, we worked last day on a bunch of different functions that it has in it. We talked about how this NumPy's array is very similar to a matrix compared to maybe another kind of list collection or something like that. It's much better than that. And what we want is, we want to move, when we start doing data science, we want to start thinking about more performance structures in order for us to be able to crunch data and do analysis. So Pandas, like we talked about last day just briefly, is, I agree with this 100% of the statement, the most popular library for dealing with data that's massive like this. Why? It sits in the middle of so many other I would say as a dependency for so many other libraries. It's truly amazing what it can do. So there's two things that it really handles well. One of them is single dimensional or one-dimensional collections. We call them series. And the other one is something called DataFrames. Series and DataFrames. You're going to see more often than not, at least in my experience, I use DataFrames a lot more than I use series. Why? Because a lot of times I have something that's very Excel-like, and I want to open up an object and open up a document that's very Excel-like, rows and columns. And when I hear rows and columns in my mind, I'm thinking either ND arrays or data frames. That's what I'm thinking for Python. Okay? Or a data frame of ND arrays or arrays. Or a data frame of series. So again, we have these two things, and what they do is they use ND arrays under the hood, which is why Pandas depends on NumPy. NumPy is like the mother of all libraries, and Pandas is like, you know, another really important library as well, like we said. Okay. So what is a series? It's a one-dimensional array, and that's kind of where it starts off. So series. One thing about series and about data frames is, and this is something that we have to deal with machine learning and even statistics, is this idea of missing data. Sometimes we'll get patchy data. Not every record is going to have all the fields filled in. And that can cause null reference errors in other programs. But not so when you use series and data frames in Pandas. And this is where it's really great, because what Pandas can do is give you the data that it has and then ignore the data that's missing or incomplete, which is awesome. That means I don't have to do a lot more massaging of the data. Here's one thing I want to tell you before I move on. One of the things we do with data science in general, as well as with machine learning. Remember I said machine learning is like kind of like statistics on steroids in many ways, right? Remember what we're doing. We're analyzing big data sets. Big data sets. We're going to have a big data set. I want to analyze it, and I want to get some results, right? And there's two things. There's qualitative data and quantitative data, right? I might have something like categorical data, color red, you know, as an example, a large or medium or small object. That's categorical data. Then there's numerical data, 0.1, 5.7, 6, whatever, numerical data. A lot of times when we do our analysis, we don't want to use categorical data. We want to break categorical data down into numerical data, which means we want to convert the categories into some kind of number, right? So we're going to be dealing with this as well, because what's happening is, for example, if I say we're going to have small, medium, and large, that's more difficult for me to wrap my mind around compared to 0, 1, 2 when it comes to small, medium, and large, right? So when it comes to calculations and so on. So series allows us to do stuff with patchy or missing data. And one of the things we do when we look at a data set is we need to clean it up a lot of times. We get a data set, we look at it, and it's garbage, lots of garbage data. So we remove stuff. We remove some columns, we remove some cells, we drop the last row, we drop the first column, we drop this, we drop that. And the reason why is we want to make it so that it's a data set, a core data set that we can consume, all right? Otherwise, we're going to have some data that's in there that might be garbage, that might mess you up. Pandas can help us with that. All right, so here's the first thing we're going to do. We're going to set up a import of pandas, just like it says here. So I'm going to go back to this. First thing we do is import pandas. And again, if you can't import pandas for whatever the reason, so if I say import pandas as PD, if you can't do this, that means that your system hasn't been initialized properly, and you need to download pandas. So you can do that by going to use pip. Remember, pip is your Python package manager. So you can say pip install pandas. Even if I do this now, it's not going to hurt me, right? Again, it might tell me that there's a new version, but it says, hey, you know what? The requirement's already met. It's not going to complain. And notice that pandas depends on NumPy, like it says, right? But pip is telling me, guess what? We've just updated our version to 20.2.1. Do you want to update? No, I'm not going to do that right now. All right. So if you don't have pandas, please do this. Next thing is inside of our main. Let's just put this in our main here. What we want to do is exactly what it says here. We want to kind of try something like our grades. Let's work with a bunch of grades here. So grades is equal to pandas series, and we'll put some numbers in there, okay? And notice the numbers we're getting a list and converting it to a series, just like we did with an ND array, okay? So that's kind of something we're going to have to look at. So I can say that grades is equal to a pd.series, and we want to wrap that a list of grades in here. So let's put some more than just 3. We'll put in, like, I don't know, someone did a 65, and then someone did a 71, and an 82, and an 85, and they did a 58. They didn't fail anything. They had maybe a bad grade, and then they did an 89, and this person also did a 91. 91 is their best grade. Yeah, there's some grades. I just randomly put that into place, okay? So that's the first thing. So make some data. Again, what we could have done is we could have used the A range, because pandas is compatible with our ND arrays that we talked about before. Now, one thing to do is notice how if I go now it just says grades. What this means is for us we want to print grades. So if I said something like print grades, and if I was to run this, Python main.py, you're going to see that it produces this. So this is where it's different than ND arrays. This produces an index. By default, Pandas always produces an index. And this is an example of a series, a one-dimensional array. So a single column, multiple rows. And we don't count this. This is just the index row, or the index column, 0, 1, 2, 3, 4, 5, 6, as an example. We're zero-based counting here again, but it produces this for us. Whenever we print it out, we have a nice output like this. It's a beautiful thing. And it also tells us the data type, int64, because none of these have been are different kind of data. If I change this to 65.3 and 71.2, and I leave the rest as is, and if I do that again, now it's float 64, even though only 2 changed. Because 2 of the series are floating point numbers, now everything is a floating point number because we want to keep homogeneous. Remember, We want to clean our data. We want to keep homogeneous when it comes to us analyzing our data set, which is what Pandas is really great for. Once we start analyzing, one thing's to be the same. And so what it's done here is it's converted everything to a float 64, right? 64-bit float. Okay? And that's that. So we've kind of did that already. Here's something we can use. We can say PD series, and I can use a value with a particular range. I can say, so I want to take this value and repeat it a bunch of times, right? So that's interesting. You can do it that way. It's like an A range that you want to do that. And again, I can look at one element by using the square brackets. So we can do that. That's kind of an index. We can do that as normal. I can do a bunch of statistics on these grades right away. Okay, so count, mean, min, max, and standard. Let's do those. So I want to definitely get the mean. So if I want to say, usually what I do is I create another variable like mean, and I say mean is equal to grades.mean. Sometimes I might call that average because mean is a keyword. I might say average is equals to grades.mean, right? And you know, I want to be able to show that out. And then what I want to do is show up my mean. So print average, right? And then just like before, we're just using functions here. I feel like I'm doing Excel. And then here's my mean. My mean is 77.357. Whoa, holy crap, it's really long. It can give me as much precision as possible, if you notice here. All right, so 77 point something is the mean. I can calculate the standard deviation. I can calculate the count. So if I was going to go to count is equal to grades.count, right? And then I want to print that out first. Let's do the count first. So print count. And you can see that the count is 7. So I have 7 elements inside of the array. That's what count does. It's like a size function. That's what that does. All right. I don't want this, that's for sure. I want this. Min, max. Min and max are very important. A lot of times we want to find the min and max to calculate things like the interquartile range between the 25th percentile, let's say, and the 75th percentile. We use min and maximum values for that a lot of times to calculate that. But you can actually just go grades.describe, which is an amazing thing, and it'll give you all the statistics, the descriptive statistics for a particular series. So let's try that. So we'll say description or DCR. We want to do grades.describe, right? Which is a function. And I want to print out DSCR, the description. And let's do one of these. And when we do that, we have this. Count is 7. Mean is 77.35714. My standard deviation is 12.6 as an example, right? So that means one standard deviation from the mean is 12.6, right? Values away from the middle. My minimum value is 58. My maximum value is 91. My 25th percentile, all right, or 25th quartile, if you will, is 68 based on my data, right? My 50th percentile, or the middle, right, that's like the median, right, is 82. And we can see that 82 might be the middle number between all these numbers. We have 7 numbers. And if we were to sort these values, it'd be 58, 65, 71, and then 82, 85, 89, and 91. 82 by chance happens to be in the exact center of the data series, right? So that's why it's median, right? And then the 75th quartile is 87. It doesn't tell you the outliers, and it doesn't do a box plot for you, but it's pretty good in terms of giving you descriptive statistics. And a lot of times we look at a series, we want these numbers, right? So for example, what this means is if you're outside the 75th percentile, right, outside the the third quartile, if you will, right, then what happens is between 75th percentile and max, which is 91, right? You can see that how many standard deviations are you away from center is what this is asking, right? Okay, so let's go back. So that's what this does. And it also works nicely with strings. So for example, I can sit there and say hammer, saw, and wrench. You can see it'll put down those as well. So this is more categorical data as opposed to, let's say, numerical data. Okay, categorical data, again, we can use it to categorize a group of a piece of data. So for example, if I have a price and I want to say the type is hammer for this particular tool, or I might have another kind of tool and the type for that kind of tool, it's a special kind of saw, right? Or a different kind of wrench. Each type would be the category, wrench, saw, hammer, as an example, as opposed to the numbers 0, 1, and 2. You can also check to see if your hardware, in this particular case the strings, contain something. So you can say, does the string contain an A? If it does, it'll create another series, just like we did with NumPy. NumPy creates another series where we can check to see if something exists, and it'll create another series of that gives us true and false values. So that's what this does, right? Again, useful because true and false are something that we can deal with, a 0 or a 1, a true or a false, as opposed to hammer, saw, and so on. Those are categories where true and false are values that I can deal with, that I can use in statistics. All right, we can also use string operations like upper and lower to create those kind of things. That's really it for series. So series, it's all around a single dimensional array. DataFrames, as an example, uses a two-dimensional array format. And what we want to do with DataFrames is it's like series in that we have we can use series for each data frame, and we'll talk about that. DataFrames also support missing data. So when we're cleaning data up, if there's pieces of information that are missing, it's going to ignore it. And we'll show you some examples of that in a bit. So here's something. In this case, what we can use is we can get a dictionary, okay? And I want to get a series, but each dictionary is going to be a set of grades for each person. Okay, let's try and do this differently. Okay, I like the grades idea because it's kind of interesting. So let me just go back to this. So what we want to do is when we name the series, right, we want to create a dictionary. Curly braces, remember, are the dictionary. And it's going to be curly braces of series. Curly braces of series. And we can call this a grades dictionary, or just call it grades with an S. Let's try this. So grades with an S, okay. And we want to make a dictionary, so let's just get rid of this. And we're going to say that each person is going to have 7 pieces of data. We'll make it more interesting than the book. So we'll say that grades is equal to curly braces. Immediately when I do curly braces in your mind, you should think about dictionary and then the name of the person. So for example, let's say we'll have Mike have that data, right? And then we'll have Jane, and we'll have another series of data. Let's see if I can do this by copy pasting and manipulating some of the data. We could also make random values, by the way. For example, if I want Mike's grades to be random, and I think that might be better for us to use. Let's do that. We want Mike's grades to be random, so let's do a couple things. So we'll import random, right? And remember what we did here. Again, what I'd like to try and do is keep it within the def main, the function main, and let's do a couple things that are more interesting for us. So Mike's grades right? We'll say that it's a random dot range, right? And remember that we can go from a start to stop, but not including it. So I want to go from something like, I want a random range, which is reasonable, but let's say between 40, so maybe Mike failed something, and let's say 100, maybe they got 100%. It's possible. And how many do I want? So I want random not ran range, but I want a bunch of them. So, question for you is, if I want a bunch of grades like this, how do I do it? What would you say? So start to stop, I want a random number, but I want a bunch of those. Do I need to do a for loop? Is there another structure that I can use? What can we do? Because you're going to get a question like this on the day. Okay, for loop. I see a for. I could totally do a for loop, right? And what I could do is I could say that Mike's grades, right? I could start off Mike's grades. I could do this is equal to a list, right? Because that's what it is, an empty list, and then I could do a for loop. So this is an option. So I could do a for. So the target list, as an example, let's say, for example, in range for for number in range, and I want to do 7. So I want to do 7 grades, and what I want is for Mike's grades to plus equal. Can I do this? Plus equal to from 40 to 100, right? Mike's grades from 40 to 100. And let's see how that works out to be. If I want to print out Mike's grades afterwards, because we want to make some random values as opposed to us always having the same value, what do we do if I want to do this? And I'm going to get an error. It says int object is not iterable. All right. So how do I add to the to my grades? I can't do this necessarily. What do I do? Well, remember, we have Mike's grades has an append function, right? And we want to append random ran range to this. This is definitely a long way of doing it, right? There's another way of doing this, but now you can see that we get some random values. Some of them, I even got a low value of 44. All right. So, but we do got 7 values for Mike's grades. All right. Let's do that for a bunch of them. And in the example, we have 1, 2, 3, 4, 5 different people. All right. So we'll do 5 different people. Okay, just to make it spicier. So instead of doing it this way, we don't want that. Not like this. We want it so that we say Mike's grades. We'll say Jane's grades. Dot append. Some random values. And we'll also say that, and Jane's grades will also be a list. So Mike's grades, Jane's grades. Who else can we use? We'll say that we also want Peter's grades. And we'll make another one. And we'll just do them all now. We'll say Steve's grades. No relation to any Steve we know. Right? And Joseph's grades. Why not? Sorry, Joseph. And you know what? Nushig's grades. Nushig's grades. I'm just picking random people. But you know what? Let's not make it random. Let's make it, instead of Peter's, we'll do Tiago. Because he, Tiago's grades. Guys, it's all random. Okay, so there's no underlying motive here, or for any kind of thing, right? So like do this, and just for the example, right? And we'll also say that Steve's grades, and we'll also go Joseph's grades and Kushik's grades. Okay, so we got a bunch of grades. Yay! And 7 of them. And then, instead of printing all this, what we want is a dictionary to do all that. So we'll say something like a dictionary where we say, we'll start off with Mike, and then Mike's grades, and then Jane, and then Jane's grades, and we'll do Tiago and Tiago's grades. We'll do it in order, and then Steve. Jeez. Steve's grades. God, that was hard. And Joseph. And Joseph's grades. And one more. We'll do Nushig. And Nushig's grades. Okay, and we'll just make this so it's spaced out so you can see it better. Okay, so that's grades. And we want to do this, we're doing this all inside of main. And now we have this dictionary. If I want to print out the dictionary, let's see how that looks, just to make sure that we have a dictionary of grades. So we've prepared our data. Nice. It's a beautiful thing. And random values, right? 52. Let's see how Tiago did. Tiago, one low grade and some good, really good ones. All right, so there we go. Lower that for 20 to 85. No, come on. And in fact, what we want to do is we want to involve a random seed because we want to make this reproducible, my friends. Reproducible. So we're going to say random.seed. We'll use 45 again, just because that seems to be the magic number. And this way you can do what I do. You'll get the same stuff that I have. I'm going to put this up on GitHub in a second. Let's do it again, and we get these values. Tiago, you didn't do bad. Look, 297s with the 45, Tiago. All right? And what did Joseph do? Oh. Not so good, right? It just happened to be that way, Joseph, I swear. There's no attack on Joseph or Nushig for that matter, or anybody else. And all the names are, fictitious and here to protect the innocent and all that stuff. I know, it's crazy. Look at that. That's crazy, Joseph. All right, so so we got some data. And that's the first step, get some data. All right, and the next step is, we'll follow the next part, which is once we have data, we want to convert our grades into a data frame. All right, so grades dict is what this is, a dictionary, right? So we're going to go back and change this to where it says grades. We'll rejig this to grades dict, a dictionary of grades. And what we want instead is we want to say that grades is equal to pd.dataframe, and then pass in grades dict. And now when we see grades, if I just print out grades the way it is, right? My God, it's a beautiful thing. And that's, my friends, why I want to use DataFrames, because it took your data and put it inside a beautiful row and column, hint for something you could have done for assignment. This is something that is a beautiful thing. It takes 2 seconds to do, and it is nice, right? It's really, really nice. Now, we can do descriptive statistics on this, right? So let's go back to this. And once we have grades, we can play with the data frame as if we have column and kind of row values. So for example, if I want to look at a data frame and where I want to say that my index, right, is instead of test 1, test 2, test 3, we have 7 different kinds of grades. So what I can say instead, so here what this says is I want to take data frames, make it out of my grades dict, but I want to use my own index. All right, so as opposed to 0, 1, 2, 3, 4, 5, 6, there's 7 different ones. So what I can say is my index is equal to, and again, what you can do is you can make it so that it is a list of values, right? So here's the list, and then the values would be, let's say something like comp 397, 391. I'm making these random values, guys. Okay, so there's trying to make numbers up. Comp 397, comp 308, comp. Comp 229. Hopefully not. And comp 228. Some of the ones that we're familiar with, and some not. Comp 392. 1, 2, 3, 4, 5, 6. One more. And to make the first one comp 1, 2, 3. Comp 1, 2, 3. There you go. So all the courses, and we're making this, and then when I do the same thing, right? It's a beautiful thing. And that, my friends, is pretty awesome, right? So you can take that index and you can replace the index with whatever number you want. You can do the same thing for series, right? So if you want a series and you want the averages, so you can see, like, you know, for example, Mike, you know, and it looks like Joseph in this case. Sorry, Joseph was the lowest, but generally people didn't do so good in comp 1, 2, 3, right? You can see that, right? I know, comp 391, what the heck? And you know, Tiago, you know what that is, Tiago? Comp 391 is intro to game and simulation, right? So it's bad. That's an actual course, right? But who knows? We're just making these numbers up. Hey, let's use a different range. This is bugging me. I don't like when people do bad. Let's do 46, okay? I don't want any of my students doing bad. Let's see what 46 does for us, because you know what it is. It's better. That's just... Whoa, that's way better. Although, Nushik, you're suffering with a couple of bad ones. And okay, maybe we'll make it from 45. You know, 40 is really low, guys. That's like, you know, the average would be really crazy. You know, so some people would fail, but, you know, I think 45 to 100 might be more reasonable, because it's like impossible. In fact, you know, even that's pretty low. Yeah, you're going to still get some lows, though. All right, make it 50, 55. So that way no one feels bad. I won't feel bad either. How about that? Or 50 to 100. 50. You passed, but you didn't do great. How about that? If we'll do it that way, just so we don't make anybody mad. Because I wouldn't want a bad thing, even on a joke. All right, so there we go. And okay, good. There we go. No one failed. I know. 44. Let's see how he did now. So Tiago, you know what? That's a much better score. Joseph, you did pretty good in some courses, really good, and pretty bad in other ones, right? Nushik, even you know, you did some bad stuff in general, and Mike and Jane, who knows who they are. All right, so so generally we have some data. So what we want to do is, if we print it out, if I want to print out a specific person, because it's a dictionary, which is what Pandas DataFrames is, I can look at a person's data. So for example, if I want to go back and I want to say, I want to see what the grades are for Tiago, let's just say, right? So I can say, okay, so I want to print, right, grades. And then it's because it's a thing, I can say Tiago, and I want to print those out. And let's see how that goes if I do it now. And so, whoa, what happened? And did I do something wrong? I probably did something wrong. Grades. No, I think I'm pretty good. Or I spelled it wrong, because it's a T, not lowercase t. There. So that shows you just your grades. Right, so you can specify one person's grades. And the great thing about Pandas data frame, it goes even further, where what if I wanted to say grades dot Tiago, like this? Is that possible? And if I do clear and do it again, you can see, yes, it does work. So it says name Tiago, data type N64. So I know it's rigged. It's totally rigged. So you can see that this is a great, amazing thing. It's almost like Tiago, or if I say Joseph, as an example, right? It becomes a property, similar to what happens in JavaScript, actually. So you see Joseph or Nushik. You know, here we go, Nushik, right? So you can see that that is totally something that is Fine, right? So there's new shakes data. So we can isolate anyone's data in the dictionary by just calling out their the name, the key for the dictionary. The values will all come out, and it'll be organized nicely like we've seen down here, which is a beautiful thing. So that's what that does. And there you go. So one thing to do is we can also use lock and ilock and at and iat instead of square brackets. So even though DataFrames supports square brackets, Pandas says it's better for them. They prefer it's preferable to use lock and ilock. And what is lock and ilock? So lock is like your it's a location, but it's the row. Okay? And ilock, right, is the column. Let's take a look at that. So row, if I want to look at, as an example, everybody's grades for COMP301. Okay, let's try and do that. So I want to see, we'll call it COMP391, right? I can say that COMP391 is equal to grades, right? And I want to use lock. And so grades.lock and then the name of the key, which is what we want to put in there. So grades.lock and then the name of the key, which is something like COMP391. Okay, and I want to print that out. So I want to know everyone's grades for COMP391. And you're going to see Mike's grades, Jane's grades, Tiago's grades. So, and notice it's put in a nice format, so I can specify which one, whose grades did what. Guys, again, this is fantastic. I've able to randomly generate values, go into the location, grab a particular piece of data, and bring it back out from the data set. Remember, the data set's pretty big, right? I mean, roughly from what it is, right? And I can bring it back out, and I can specify which key was accomplished what. And then once I have this grades.lock, I can do descriptive statistics on it, right? Which are really cool, man. Remember, statistics on steroids. So that's the first thing. So I can grab this. ilock, on the other hand, right? So I can access rows by integer values. So again, instead of using square brackets by themselves, I can use ilock and then the integer. So why this, as opposed to something else? So for example, let's go back, and if I said I want to get COMP391 by ilock, and I know that COMP391 would be row 1 or row 1, right? Okay, so I think, yeah, that's got to be taken away because it's an actual index. And if I said this, then you're going to get the same data, but it's going to say name is COMP391, but we're going to use ilock instead. Sometimes you want this instead of the key, right? Or the index. Because the index, it's nice because it's key value pairs, but sometimes we want to do a calculation, or I want to loop through something and I want to show things like loop through with ilock. All right. So again, lock is location, but you can use your friendly names for the key. Ilock, number. That's the difference between one and the other. Okay. With ilock, though, you can do a lot of slicing. We've talked about slicing before, and we're going to get into that in a bit, and other things. All right. So lock. I can do slicing with lock too. From, let's say, for example, I want to go from COMP391 to whatever I want. Okay, so I only want to select courses, not all of them. So again, I can go, we'll call them select courses. So we'll say game courses. So game courses, right? And that's equal to grades equals to lock. And then I want to go from COMP391. I kind of didn't group them together, did I? Let's switch these around just so that way we'll make them we'll put all these courses together, the ones that are that makes sense. Sorry, I just want to make sure that we give you a good example. So we'll say these ones, and we'll also say this one here is at the end. Sorry, we're going to split your grades now, okay? Split your grades. And there's that. And you know what? Let us add another row for COMP301. Why not? So we'll say COMP301. So we'll add the 8th grade, and that means I'll add 8 in here instead of 7. Okay? 8 instead of 7. There's 8 grades, and I want to go from COMP301 to COMP392. So for courses that include, so 391, COMP397, COMP392, right? Those are all grades dot lock. So I want to get a range. I want to say game courses, and then we want to say print game courses. Okay, let's see what that looks like. We're gonna have another field, and I made a mistake somewhere for sure. 1, 2, 3, 4, 5, 6, 7, 8. Good. We got these ones, and we have a range of 0 to 8. We did that one right. And what did I do wrong with this one? Oh, I want to do from here to here. It's a slice. It's not a thing. Here we go. So let's do that again. So it shows us all the courses. So you see, sorry guys, I swapped things around, right? So COMP391, these are all the game courses, these ones, and then these ones were non-game courses, these ones here, okay? And you can see how you guys did some good ones and some bad ones. Tiago, I don't know, man. I don't know, man. It's 81, 54, 69. So that's how it goes. Yeah, the roles are definitely rigged. Absolutely. All right. So yeah, so now you can see that for the game courses, this is how people did. You can specify a range of values if they were grouped this way. Okay? Which is kind of neat. All right. And same thing, I can go from 0 to 2 instead of using the actual names. This is a lot of times I find easier than actually putting in those things. You can make the index, but maybe I want to go from column 0 to column 2. It's the same values, right, that I would have had before. Okay. I could also indicate a list, so I can specify values in a list that can. So let's say I only want 2 different values that are on different places. I can specify it that way. I'm not going to do that because you can see how it works. And then I can describe, and this is what I want to get to. So I want to say, just like we did with the descriptives, the descriptions, right? I want to say that descript is equal to grades dot describe, right? And then I want to print out description, the descriptive statistics. Let me just not print out these ones anymore because I don't want to see these. It's not important anymore. Okay, so there we go. And save, and we just want the descriptive statistics, and there they are. So we can see that the total count for everybody, here's the total count, and let me just do that again. It's reproducible results. We're going to get the same numbers. So we got that the count for Mike, Jane, Tiago, Steve, and Joseph and Ushik, they're all 8, so 8 courses. And the mean, you can see that the mean for the courses roughly run for, and this is for each column, right? So we're sitting at 70, 67, not a great mean. Let's see if we can improve that mean by changing up the seed. So we'll say, let's go to 46. I think 46 was better numbers anyway. And let's clear that up. Maybe, maybe not. Let's see how that goes. Yep, better numbers. Those are better numbers. I mean, there's some, you can also show you the standard deviation for all your grades, the minimum grade that you had, the maximum grade that you had, as well as your the quartiles. So the median, that would be closer to your GPA, 79.5 as an example, Joseph, or 72.5 Tiago, or 65.5 for Nushik, right? As an example. So that would be your medium, and that kind of takes that data and spits out the details right away. And I don't have to use an Excel spreadsheet for this. I can just literally do things with Python. Okay, so that's pretty powerful. And that's what the idea is here. The Python allows you to do this stuff. Look, in a few minutes, we can take a data set, analyze it, spin it around, and we can actually do other things to it. I can also set up options, like I only want precision of 2 decimal points. Let's try that. So we can set option, which is something we can put on our data set. So we can say that for all pandas, in this particular case, before we start, I can go to, at the beginning, I can say pd.setOption, and I can say precision, right, is equal to 2. How does that go? Yeah, precision is equal to 2, comma 2. So precision, and then that's the option, comma 2. So that's like, you can see the precision, and then, or the option, and then the value. That's how it works. So if I was to do that and clear and do the thing, you can see now it goes back down to values that make sense. Okay. Otherwise, it's the same values, just the precision that's showing is not at the same level. All right. So some interesting stuff here. If I want to find the transpose, I can do that too. So transposing swaps rows and columns. That's what it does. So I want to find, all of Wally's grades, all of Eva's grades, all of Sam's grades, but I want to do it in rows as opposed to columns. I can do that too. So let's do a grades.transpose. And by the way, when we do a grades, we can also chain them together, I believe. So if I said something like, all right, I want to transpose the grades, but I want to describe the transpose values, right? So if I did this, then I can do this. You'll see that there are 6, right? And I can have the, so 6, why 6? Because I have 1, 2, 3, 4, 5, 6 people, right? And now what I have is, what is the average for COMP301? How do people do, right, on average, right? So the mean for that course is 69.83, right? What is the average for COMP125? 74.67, and so on. Okay, what is the minimum? What is the maximum? And so on. Okay, so that's transposing data, as opposed to just flipping rows and columns, right? So I want to know those statistics. If I just did the transpose just by itself, so if I just said don't describe, right, as an example, I want to see that data. So let's suppose I want to see the grades up here, and we'll just make a little separator too. So let's say we want to make a separator like this, maybe reasonably even larger, like this, separator, and I want to get grades dot transpose, right? So I want to see that. What will that look like? Well, it'll look like this. So you see Mike and Jane and Tiago and Steve on the left, and then you see the the columns on the top, right? So you can say, well, let's look at Mike's grades, let's look at Jane's grades, let's look at Tiago's grades, right? You can see that might be something that's more natural to you for you to look at than some of the other things. All right, so kind of cool. You can spin data, which is what this does. Transpose view, it actually changes the data frame. It's not a copy when you do that. All right, and that's what we did with describe. And I can also look at the mean or a specific value, just like we did for the other ones. So guys, that's where I want to stop today. I don't want to go beyond that. I think we've covered a lot of different things here in terms of new stuff, all right, that we covered. So this is like how to use pandas data frames, okay? Now, let me put this up on GitHub for you. So, and I know we made a copy, so we have to rejig what we're looking at. So we'll say git remote minus v. We can see that that's looking at a less than 11. And what I want to do instead is GitHub. I want to go and make a new one. So I want to do COMP301 and the summer 2020 semester, and it's less than 12. Oh, darn it. Did I do it already? Oh, good, I didn't. That would be a pain. And I want to grab these last two lines of code and copy them. Now this is where it may not work the same way that I want it to work. Like, right? So I want to, may have to copy this by hand. Copy, and then paste. And sorry, I have to remove it first. And then do that. Okay. And then push minus U origin master, which will push up to the new remote. And now you should have that in your GitHub repo. Now we're going to add to this because we added mains. We'll say added pandas data frame. Okay, so you're going to have the other stuff from last week as well. It's embedded in here because we did that work. Okay, and I don't want you, if you wanted to go back and check it, it's here for you to check. But we're going to do this. We're going to say check mark and push. So that's going to be up on GitHub as well. So you can see there's a lot of power here. But where this really takes off is when we use things like scikit-learn, and when we do some kind of machine learning. So if I was going to look at machine learning, I'm looking at on the PC side now, just to make it easier. If I look at scikit-learn, let's go there together just for a second. I'm going to try and cover some of this on on Thursday. You can see that there's different kinds of things we can do. All right. So classification, right? Regression's kind of like a projection, if you want to say something. Clustering, right? These are examples of what you can do with machine learning. And again, notice it says built on NumPy and SciPy and Matplotlib, right? So these are the basis for doing scikit-learn. Okay. So if we look at some of these data sets, and they give some examples of this, they also talk about things like dimensionality reduction when you do a three-dimensional data set, different model selections and pre-processing, and a bunch of other stuff this can do. This is where we build on one thing on top of the other. So let's say, for example, I want to do regression, which is probably some of the easiest things to do. It gives us some examples on how to do that. So here's NumPy as an example, and we can look at decision tree regressor. That's a type of way to do it. All right, and then that's a structure, if you will, a data structure. We can use an ensemble method, right, to import ADA boost regressor, which is a type of regressive algorithm. And then what they do is they get a random state, right? And here they're using linspace, right? Remember, linear space from 0 to 6, right? 100 values from 0 to 6, evenly spaced values from 0 to 6. Okay, remember that's what that does. Okay, and they do some regression. This is what machine learning does. This is exactly what's happening. So when you look at this, you're like, wait, what? What is this doing? Well, you should be able to read some of this now because we've covered some of these values. So linear space between 0 and 6, 100 values between that. So that's your x value. And then what you're going to do is for your y value, because you're going to get your x and y values for this, you're going to go, you're going to use the sign, and you're going to add up for each of the y values. You're going to get a particular y value, right? And it's going to give you a range. It's going to give you a list as well. And then what you're going to do is you're going to take this data, x and y values, and remember, you're getting x and y values on a plot. And what you're going to do is you're going to plot these values out. But what you're also going to do is, what a decision tree does is it kind of looks to sees where, when I have, kind of, depending on the values that you're going to get, right, you're going to try and create a fit for all the data that you're going to get, right? So if I was just going to take this part, let's not take this part. And I'm going to start with just the stuff that's online here, okay? Don't worry about understanding everything. We understand a lot of it already, okay? But the trick is, can we get sklearn imported, right? Like, is that even installed? And if you haven't installed it, then you're going to see that if I did something like, let's try this out. So I'm going to go, we'll just call it ml.py. So this is the first time we're doing this, ml.py. And then we're just going to see if I can drag and drop from outside of my thing. So I'm going to grab maybe just this. How about those parts? All right. I'm going to copy this and let's see if I can paste it in my VM. Maybe. Yeah. All right. So a couple things that are good. We're not using sklearn right now, right? But I want to get numbers for big X and lowercase y and see what I get there. All right. So let's print that out. So print X and print y. All right, let's see what that looks like. And remember, like we said, we just want to kind of get an understanding of what's happening here. So Python, and we want to say ml.py. Whoa. All right, so that took a while. And remember we talked about this? It generated values, so 100 values between 0 and 6. 0 and 6, 100 values, right? And notice that it created a array, okay? An array, remember, between 0 and 6, and evenly spaced values. So 6 should be the top value. There's 6, and including 6. All right, 100 values between 0 and 6. Okay, so now what did sign do? So sign created what looks like a list, right? A list of the same number of values between, and random, what looks like random values, right? So now we have X and Y coordinates. If I have X and Y coordinates, I can plot these random values, as an example, on a graph, right? Which what we're doing next with our matplotlib, right? So again, going back to this. Before we do any kind of regression, okay, I don't want to do regression yet. I just want to plot X and Y coordinates. So here they modify X and Y, right? And because they're using, well, we'll do the next part. We'll just copy and paste everything. So you see that we'll see what it does for us. How about that? So copy, and then you don't need to print this anymore. And let's see what happens. Right, paste. And what it's going to do is create a scatter plot, and it's also going to make a line. And the line that's going to be in the middle is the line of best fit. That's what it's going to show. Okay, so let's just clear this up. Okay, let's do it. And did we not save? We did not save. Let's try this again. We should get a graph out of this. Yay! So what's happening is now this is a decision tree regressor, right? That's what it is. And you see this line. This is the what's happening is the line of best fit. And what's happening is you can see that there's some outliers over here and over here, right? But what's trying to happen is it's trying to predict, right? It can't do all the data points because there's going to be data points in between. And what this decision tree regressor is trying to do is trying to figure out when we have an estimator equal to 1, it's going to give us kind of a square graph, right? But when we use 300 estimators, so we've gone through this value a bunch of times, it's going to get closer, and you're almost getting, kind of a line of best fit. What you don't want to do is make the sample too big, because then you're going to get something called overfitting happening. So if I have other data, if I throw other data at this, you might get the wrong kind of data. But here what you're getting is, you can see how it's predicting, even though we have this many values, right? So from values from the scatter plot that we use, right? And this is without, if I just wanted to show the values without the regression, so let's say, for example, we just want to show the x and y for the scatter, and I don't want to plot anything else. I don't want to plot the g and the r, right? These things here, right? So let's just comment these out. So remember, we can just do this, right? Because, oops, undo. Because we should know how this works now, right? So here's plot, and X label and Y label and boosted decision tree regression is what this is called. I don't care about the legend. We don't care about that at all, because we're removing a couple of these things out of there. But we just want to see the scatter plot and see how that works. So again, did we not close it down? We did not. And let us do it again. And now you can just see so you see data like this, and you're like, what you want, and this is just using obviously a sine wave. That's why it looks very sinusoidal. You want the graph, you want your line of best fit to kind of fit inside those data points. But remember, we don't have every data point in that line, right? We want to create a line that's the best fit between all those other data points, right? But also accommodate for new data points in the future if I had other ones, right? So that way it would understand how to do that. So that's what regression does. Regression is kind of, it calculates or predicts the line of best fit based on the data points that you're giving it. Okay. And you can change your estimators. So if I change the estimators down from 300 down to 100, right? And if I put these values back, and instead of estimators are 300, estimators are 100, we can also put back the legend for a second to see the difference between what we have. So here we have an estimator that's equal to 1. Let's make this estimator equal to 10 to see the difference. And it's always good to play with this kind of stuff. For y1, right? You're predicting based on the this is the regression line for y1, right? Regression 1, this is like a maximum depth of 4 using a decision tree regressor as opposed to using AdaBoost. This can't change. I'd have to use the same AdaBoost regressor for both, right? This is just an algorithm. The decision tree regressor is an algorithm that you can use to try and predict what's happening, all right? So let's see how that looks. So that is, instead of 300, that's 100. So you can see it's a little rougher than what the other one was. And it'd be nice to see, kind of a different value, what it looks like if it's 50. So we can add that in, right? Because you can add as many of these plots as you want. So let's say that, let's do the difference between this one and, sorry, let's do one of these. And let's say regression 3, we'll do another regression chart. And we're using AdaBoost regressor, and we'll make it 500, right? Okay, so 500, max depth 4. And we'll say that regression 3 dot fit big X and lowercase y. That's usually how you do it. And what we want to do is we're going to say that y underscore 3 is equal to regression underscore 3 dot predict X capital. So this is going to make another line of prediction. That's what this is going to do, predict where the thing is with a different number of estimators. The more estimators you use, the closer you're going to be, but also you can get to the point where you're overfitting, which is not what you want to do. All right, so let's do 500 there. And I think we have everything we need to make this work. Pretty sure. Okay, let's try it again. So clear and Python ML. So we should have 3 lines now, and we do. But one of them is also red, and it's superseding the other one. Let's make it a different color. Estimators. How do you change the color? There's a way of doing that. Is there maximum depth? I have to look it up. Let's green, red, and this will be blue. Let's say blue. There we go. That's how you do it. And ta-da! All right, so you can see that when you have 500 estimators, that it's almost the same as 100 estimators, right? Almost. 100 estimators is slightly wilder, and if you even go further down, let's say, for example, instead of 100 estimators, you go to 20. All right, so let's say this is 20, and that's 500, and let's say the difference between that and the other thing. And you see now that the lower number of estimators are rougher and produce more error than the higher number of estimators, but you can see that the lines still follow the path. So you're trying to estimate the best fit line of best fit based on the data that you have, and that's really, in a nutshell, what regression is. Whew. Make sense? Confused? That's okay, because when you first start doing machine learning, I was confused too. When I was looking at it, I go, okay, no problem. I got lots of data points, and what are these lines? Lines of best fit. You're trying to make it so that you can predict the next data point. Now think about this. If I have a bunch of data points in real life, not just these random numbers here, right? I have a bunch of data points, and I want to predict the next data point, whatever that's going to be, right? And if I have a line of regression, I can expand this to say, okay, what's the next? What is the next data point? The next data point. The next data point is going to be based on kind of the line of best fit, without having every single data point. Not everything is filled in, but we're able to draw a line that's solid, right? And that's what machine learning does a lot of times. It predicts based on the trend that you're seeing, right? The line of best fit, and it excludes things like these outliers here, which are outside of the average numbers. See how it excludes these ones? If it was to include these ones as well, that would be overfitting. It'd be too much. Because then if you put new data in, then that would be wrong. Okay, that's it for the statistics lesson today. So next day we're going to do more of this, few more examples, but more or less they're just for your understanding. It's for enrichment purposes. So really today would have been the official last lecture. On Thursday we're going to do more of this kind of work, where we're going to explore different types of machine learning techniques and how they base a lot of the and at a very high level. We're going to explore them. I'm not going to go into a lot of detail here, because it's the subject of a whole program, not a course, program of stuff that you can learn on how to apply some of the stuff that we've learned this semester, to make use of it. Here we're just regurgitating the code that we've got off the internet. We're not really taking a piece of code and trying to figure out what techniques to use to understand the data. Okay, we're not doing that. Okay. Any questions around this stuff? And again, it's just an understanding of how this works. I'm going to put this up on GitHub for you guys, but this is just basically a copy paste from our website there. So I'm going to say added ML example, and we'll add this in, and then we will push. We got all that now. Okay, that's it for today, guys. I'm going to stop recording, and I'll wait around for any questions you may have. Otherwise, I'll see you guys on Thursday.